Hi, I'm going to take up where we left off a while ago with Desmos. And remember, the goal was to write quadratic equations in vertex form, root form, and standard form. But now I'm going to apply it to a real world situation or a pictorial representation of something that could be quadratic in the real world. And you can see here we have a picture that I downloaded from the TI website. And it's a program that shows the path of the ball being parabolic in shape. Now, looking at this, yeah, it looks pretty good. And I'm going to show you how you can insert a picture into the graph and set some things up, and it makes this real powerful. Uh, when I click on the next page, I notice that an XY coordinate grid has been produced, and I can't move or adjust these, or I can't slide it around, which is very important because kids will play with it and readjust everything and makes all the numbers totally different. So I'm also going to show you how you can come out here and you can add a coordinate grid. So you go to view, go to grid, and then you can interline grids. Okay, so now you can kind of see where the y-intercept is. You have the maximum value. You can tell what height the ball goes in, and there's lots of applications that you can apply here. Now, what's really important for us, or for what we're trying to do, is I'm going to hit tab, and then we're going to run through. Well, we'll try x to the power of 2. Okay, because we want them to write quadratic equations. And then you can see that this shows up. Now, with playing with the buttons, they can hit tab again, or they can double click on the equation and then they can adjust it. Well, now I'm going to make it negative x squared, excuse me. And now you can see that it's facing downward. So we're trying to get what they finished in Desmos and see if they can apply it to match the graph. And that's what it is. They're trying to make connections between the numbers that they have on this picture to an equation. So I'm going to double click over here and I'm going to readjust it. Okay, now I've did some work and it is 1/10. This is what I found, although there are several variations and some that could be a little bit closer. This is the one that I was pretty satisfied with. And I have it in vertex form. When I hit enter, then I can see that it traces the ball's path fairly well. Okay, so now remember, the goal for the students were to put it in vertex form, root form, and quadratic form. Well, having this one, now they can see the roots, and then they can plug in the next one. Now they can hit tab, and once they hit tab, as you notice, now it goes to f of 2, which is a different function. So I'm going to plug in the answer. I've got, excuse me, negative 1. Let me move that out of the way. Negative 1 divided by 10, parentheses, and then looking at the roots, that's going to be x plus 2, and then x minus 16. And then I see that, well, that lies directly on top of it, which is what we want. And then the last part is to put this in a standard form. Now they could try it, and since standard form has 3 variables, it's going to be very tricky for them to try to manipulate it. And they did that with the Desmos, but this time I would probably tell them, do a little paper pencil work and multiply these two binomials and then multiply by negative 1/10 and see if they get the answer. So I came up with negative 1/10 x squared. And then I have plus 14 tenths x plus 32 over 10. And you can see that all 3 of these graphs line directly on top of each other, and that way they can see the connections between the numbers of one equation with the other and then the third, and see if they can manipulate them correctly. I'm also going to show you how you can create this picture by yourself. If I come over here to File, I'm going to start a new handheld page, and I'm going to add a graph. Now this puts a coordinate grid on here. I'm going to click on the inside. Now earlier I Googled a picture of quadratic problems and I copied it. So now I'm just going to paste it right on top of here. And here I have some pictures of some fountains. and this is pretty good. And I could use this as is, and I could try to get them to do this, or I could, if I wanted to, I could manipulate this graph, and I can put it wherever I wanted to. I could either put it right here and say, in respects to water level, or if I wanted to say the water level that's above the pool rock, I could do that, which is kind of what I want. But the only problem is if you send this to the kids, undoubtedly they can move some stuff around and then it becomes real hectic. Well, that's not what I got. And if you want some continuity with your problems, you can lock this in. So I'm going to choose this point. I'm going to right click, and here it says pin. Well, now I can't move this. I can't grab it, and I can't move this around. And I suggest that, if you use this, that'd be something that you would use. Now, you can adjust the axis by grabbing it, moving up and down. And I think I'm going to leave mine right here. And then right over here, as you notice, my roots aren't whole numbers. And I can move that around. And I think that's more interesting. The kids will say it's tougher, but I think that's more interesting. So I'm going to move it where the roots aren't whole numbers. And then I'm going to pin that down. So right now I've pinned the axis so it doesn't move around. And I also move the axis. And you can tell by this icon it said axis, and then it has a little pin, which means it cannot be readjusted. I could also change the color of this to what other color they have available. So I'm going to do red so that it stands out. And now I can do what I did earlier. I can go to menu, I can go to view, I can go to a grid, and then I could put it either a dot grid or a line grid. I like line grid because it looks like a coordinate plane. And then you could send this as another assessment. And the good thing with Inspires is you can send this wirelessly, or you can upload it to their Inspire from a docking station straight from your teacher workstation. And then they can attempt to get the equations that make sense for this situation.